display is just about complete for tonight's parent-teachers meeting. Mr. Peterson is ready to turn on the lights. There are the lights. What happened? The lights have gone out. Perhaps there are too many lights connected to one outlet. Mr. Peterson will check to see. Barbara and Jimmy are interested too. The first thing to check is the circuit breaker. Mr. Peterson explains that a circuit breaker is a safety device that opens automatically if too much current flows through the circuit into which it is connected. The circuit breaker switch is open because the circuit was overloaded. But what is an overloaded circuit? Barbara thinks she knows. She remembers that just the other day she was using electricity for cooking. She plugged the cord from the frying pan into a wall outlet. She was also using an electric toaster. She plugged the toaster into the same wall outlet. Then she turned on the frying pan and started the toaster. But something was wrong. The appliances weren't working. They weren't becoming heated. Dad saw the problem. He explained to Barbara when she plugged the frying pan into the outlet and then turned it on, it became part of an electric circuit. He sketched a circuit to show her what he meant. The circuit is made up of one wire that leads from a generator, the source of current, to the house, to the pan, and a second wire that leads back in a continuous pathway to the source. The amount of current that flows in the house circuit is measured in amperes, sometimes called amps. The frying pan carries about 11 amperes of current. This is all right because the wires in this circuit, as in most house circuits, will safely carry 15 amperes of current. Dad reminded Barbara that when she plugged the toaster into the outlet, she had connected it into the same circuit that the frying pan was connected to. Remember that the frying pan carried 11 amperes of current. The toaster carried 10 amperes. That's a total of 21 amperes. This is an overload of 6 more amperes than the circuit was designed to carry. Fortunately, the circuit was protected by this safety device, a fuse. In the center of the fuse is a fuse wire through which the current passes. With the glass top removed, we can easily see the fuse wire. This wire, or strip of metal, will carry 15 amperes of current without melting. Let's see what happens to the fuse when it is placed in a circuit carrying more than 15 amperes. We'll gradually increase the current. The fuse wire becomes overheated and melts, or fuses. This breaks the circuit and stops the flow of current. Let's watch the fuse melt again, this time in slow motion. Once again, we have removed the glass cover so that we can observe the melting, which usually occurs in a split second. Now, what would happen to an overloaded circuit that is not protected by a fuse? The wires in the circuit may become very hot. If not properly insulated, the overheated wires may cause the material around them to burn. And so, Barbara's father pointed out that the proper size fuse in the house circuit had interrupted the current, and so prevented the overloaded circuit from becoming a fire hazard. Mr. Peterson said that a circuit breaker serves the same purpose as a fuse. It also keeps an overloaded circuit from becoming a fire hazard. With this transparent model, we can see how one kind of circuit breaker operates. When the switch is closed, electric current flows through the circuit breaker. But an overload causes the switch to spring open, like this. The open switch breaks the circuit and stops the flow of current. Unlike a fuse, a circuit breaker does not have to be replaced. It can be reset so that the switch is closed. But before they reset the circuit breaker, Mr. Peterson says they must make sure the circuit is no longer overloaded. He corrects the overload by plugging some of the lights into a wall outlet, one that is on another circuit. Before they turn the lights on, Mr. Peterson suggests that they check for another kind of trouble, a short circuit. He checks the wiring. Jimmy says that he learned just the other day what a short circuit is. Jimmy and his father were building a new table. They were using Dad's electric drill. Because the cord would not reach the electric outlet, Jimmy's dad asked him to get an extension cord. Jimmy found an old extension cord and plugged the drill cord into it. Then he plugged the extension cord into the outlet. That was a short. Dad unplugged the extension cord and checked it. The two wires in the worn plug had come in contact with each other. No great damage had been done because the fuse had blown, breaking the circuit. And why had the fuse blown? Well, when the two wires in the end of the plug had come in contact with each other, they formed a circuit with very little resistance. This short circuit allowed the wires to carry much more current than they normally carry, which is an overload. Jimmy knew that if the overloaded circuit had not been protected by a fuse, the wires could have become overheated and a serious fire might have been started. So, short circuits and overloaded circuits may create hazards in our homes as well as in our schools. It's important to remember that the use of electricity involves our personal safety. One safety rule is, never let your body become part of an electrical circuit. If you do, current will pass through your body and you may be electrocuted. You can become part of a circuit if current passes through your body and into the ground. This is called being grounded. Grounding may occur if you touch a defective switch or appliance and at the same time have contact with the ground. Water pipes make grounding possible because the metal pipe will conduct electric current and it also has contact with the earth. When a concrete floor that is in direct contact with the earth is wet, it may also conduct the current through your body to the ground. It is equally dangerous to become part of a circuit by touching water, which is being piped from the ground, and also touching a source of current. The current may pass through your body, through the water pipe, and into the ground. You may become part of a circuit when you're standing on the ground itself. It is dangerous, for example, to fly kites or model airplanes near power lines. If the line holding the kite or plane is wire or wet cord, and if it should touch the power line, current will pass through your body. A fallen power line should be reported to authorities at once so that proper precaution can be taken to keep unauthorized people away from the fallen line. Be sure, too, that you know the first aid steps for treating someone who has received an electric shock. Like Barbara and Jimmy, you will be using electricity all your life. Electricity is a valuable servant, but remember that it can be dangerous. Be sure that you use it safely.